In this video, we are going to do some important questions from the chapter Acid Basis Salt, class 10th, second chapter, chemistry. The question is, what happens when a solution of an acid is mixed with solution of a base? Now, the first thing we know that an acid reacts with base to form salt and water, and that's called neutralization reaction. So neutralization reaction is one, and one more thing, acid reacts with base. Let me write down the general reaction. What we know here that acid reacts with base to give salt and water. So as I can see that one of the option is given as salt formation takes place. Now, the other things is that this reaction that is called neutralization reaction is an exothermic reaction. So heat will be released. I can see there is an options. The temperature of the solution increases. So if I see the correct options, temperature of the solution increases and formation of salt takes place. Well, other options are given here is temperature of the solution decreases. Not true, as not an endothermic reaction, and the temperature of remains same. This is also wrong. So it's 1 and 4. 1 and 4. The option is, the option C option is correct. The option C is correct here. The next question says that the pH of the different solutions are given below. Like the pH of P is between 2.2 to 2.4 and so on. The substances are given. Now we have to arrange the solution in increasing order of H plus ions concentration. Now, first of all, you should know that regarding the pH, lower the pH, more is the acidic, right? So we can say that P is more acidic than R. If I talk about the acidic, now I'm not talking about the pH, I can say P is more acidic, right, among them because it has the lowest pH. And next is R, right? So R is acidic in nature, but has a lower in acidic strength, and similarly we'll go for S. So what I'm talking about here is the strength of an acid is determined by the pH. Lower the pH, higher is the strength. Now coming to this question, it says that H plus ions concentration. This is important that those acids which completely ionized to release more H plus ions. That means higher the H plus ions concentration, more is the acidic. So one more time, we are actually looking for these PQRS, which is in increasing order of their H plus ions concentration. So we can now conclude that the highest H plus ions concentration will be there in P. And the lowest pH high H plus ions concentration is over this. Since we have to arrange in increasing order, I'll say that the lowest H plus ions concentration is this from low to high. That's what we know about increasing order. Then after Q, the next is R here. This is R. And the next, no, not R. This is S. This is S, right? And next to S, it is R. And finally P. One more time, you should know that this is pH. Lower the pH, higher is the strength of an acid, or more acidic it is, and more acidic, more is the H plus ion. So in turn, we had to arrange them from the lowest acidic strength to the highest acidic strength, and the option will be D in this case. In the next question, it says what are strong and weak acids, and we have to segregate these acids as strong or weak acids. Options are like not options, these are the acids given here from which we have to segregate. Now the first part, what is strong and weak acids? So what we know that the strength of an acid depends upon the H plus ions. Well, for base, it is OH minus ions. And it is not the number, it's concentration. That means higher the concentration of H plus ions, stronger is the acid here. But by definition, we say that those acids which completely ionize, right? Those acids which completely ionize to produce H plus ions are generally called strong acids. And what are weak acids? Those acids which partially get ionized. Like in case of hydrochloric acid, when it is dissolved in water, it completely ionized to produce H plus AQ or H3O plus called hydronium ions. So these are considered as weak acid, a strong acid. But those acid which gets partially ionized, that means if I say take an acetic acid, which is a weak acid, then when it is dissolved in water, it does not get completely ionized. We say partially ionized, and that's why they are called weak acid. One more time, those acids which completely ionize when dissolved in water in the aqueous state, these are called strong acid, and which gets partially ionized are called weak acid. Now, from the list, it is easier to segregate, like hydrochloric acid, which is a mineral acid, is a strong acid. Then we have sulfuric acid, is another strong acid, again a mineral acid, and nitric acid. These are obtained from minerals. That's why these are called uh, mineral acid. Otherwise, also they are strong, and strong in the sense they are corrosive in nature. They causes burn, sometimes severe burn, when comes in contact with our skin, and that's why we handle them carefully. Now, the other acids which I can see, that citric acid found in the citrus fruits has to be a weak acid, as you know that we consume citric acid. Acetic acid, which is a part of vinegar, I mean 5 to 8% of acetic acid is vinegar. This should also be considered as an weak acid. Formic acid, which is found in the ant sting, but this gives us a burning sensation when they inject this acid, like when the insect, an ant bite, maybe not ant, like bees, and yeah. So when they bite, they inject this formic acid, and they causes burn. But this is not a corrosive in nature, does not gives a severe burn. That's why we consider this. So the one which I have blue shaded, these are weak acid, and the one which are in red, that is hydrochloric acid, sulfuric acid, and nitric acid, are called strong acid. Citric acid, acetic acid, and formic acid are the examples of weak acid. The next question, which is based on chloralkali process. So the question says that during the electrolysis of brine, this is electrolysis of brine. Brine is nothing but sodium chloride, that is common salt dissolved in water. So this is NaCl plus water. This together is called brine. It says a gas G is liberated at anode. Now, let me first write down the reaction involved, that will bring clarity, that when this brine, that is NaCl plus H2O, this together is called brine. When electricity is passed over it, three products are formed. One is chlorine gas, second is hydrogen, and the third product is sodium hydroxide. Now, when I read it further, it says that gas now we can see there are two gases produced. Now they're talking about the gas G is liberated at anode. Can you see this anode is that positive terminal of the battery, and at anode what is produced? Chlorine. Well, you can even easily remember that chlorine is negatively charged. That's why it is collected at the positive terminal of the battery, that is anode. And but let's stick to the question only. So we can identify the gas here. The gas G here is G. What G gas is? I can write the gas G is chlorine. So gas G, we got to know that as chlorine gas. This is chlorine gas. When the gas G is passed through the slaked lines. So what is slaked line? Slaked line is, let me make space and I'll tell you what is slaked line. So slaked line is, yeah, I got it. So this gas, that is chlorine gas, is passed over slaked lime. So chlorine gas on passing, this is chlorine gas when passed over dry slaked lime, that is slaked lime is CaOH whole twice, right? When the gas G is passed through the slaked lime, a compound C is produced. So what do we know? That when chlorine gas is passed over dry slaked lime, bleach is formed. Bleach is calcium oxychloride, right? This is bleaching powder. In fact, calcium oxychloride is the chemical name. Now, which is used as a disinfecting drinking water? Well, this is one of the common use of bleaching powder. The bleaching powder is used as a disinfectant. Now, begin with the question they are asking. The first question they are asking, what is the formula of G? We have identified this is chlorine gas. And that of C is the product which is calcium oxychloride, that is bleaching powder. State the chemical equation involved. Well, there are two chemical equation involved. One is this and other is this. Now, are there more? Yes. What is the common name of the compound C? The common name of the compound C is bleaching powder, but its chemical name is calcium oxychloride. Yeah, they have asked for the chemical name as well. So this is calcium oxychloride. I should write it. This is Ca. This is calcium oxychloride. So these are the three answers of this question. Now we have the third question here. It says, whatever be the number, we have to state the reason for the following. The first part is tap water conducts electricity while distilled water does not. You should know that for any liquid to conduct electricity or say electrolyte, it must have some ions present, or ions can be positively or negatively charged ions. Now we know that distilled water has no minerals or no salt present in them, therefore it does not conduct electricity. But when we add small amount of salts, maybe sodium chloride, it ionizes, and these ions are responsible for conduction of electricity. While tap water, even the mineral water that we drink, has some amount of mineral dissolved, and these minerals in the form of ions are responsible for conduction of electricity. So you may just say that tap water conduct electricity as it has ions. Tap water, you know what is a tap water. Now coming to the next part, that is dry hydrogen chloride gas does not turn blue litmus red, whereas dilute hydrochloric acid does. Now dry hydrogen chloride gas, that is hydrogen chloride gas, does not turn the dry litmus paper blue to red, although this gas is acidic in nature. But as we know that acid source is acidic strength when it is dissolved in water, that means in the presence of water, so therefore it will not so there are two options: either you can dissolve this acid in water, or you may moisten the litmus paper. If you moisten the litmus paper and bring near this gas, it will turn the lime water, sorry, it will turn the litmus, that is the blue litmus, red here. Well, we have the third part. And what is that third part? We highlighted the third part. During summer season, the milkman usually add some amount of baking soda in it. What you should know that baking soda is a mild base, right? So a mild base is used here, and the mild base role, you should know that the you know that uh, milk contains lactic acid, and it gets spoiled easily, and that's the reason the milk has to be consumed within the same or the next day. So its pH is around 6, right? The milk, the I'm talking about the fresh milk, has pH around 6, right? So by adding the baking soda, as I told you that baking soda is not adulteration. Like baking soda is basically a mild base, so it shifts the pH from 6 to slightly towards the right. So this allows the milk to change to lactic acid and makes it sour. I mean, the lactic acid is responsible for making it sour, or the milk becomes sour. We say milk got spoiled. So to delay that setting of or spoilage of milk, in the summer particularly, which is a favorable condition for the bacteria to grow, and that's why the milkman adds a small amount of baking soda to prolong the use of milk. That should be the answer for this. Now coming to the next and the third part, it says for dilution of an acid, acid is added to water and not water to acid. Well, you should know that the reaction between an acid and water is highly exothermic. So whenever, if let's say, for example, if you want to dilute an acid, like this is an acid, you should never put water on this. You should never put water, because the reaction with an acid with water is highly exothermic. So large amount of heat produced, highly exothermic, and there is a good chance that there is a chance that these acid will splash out. Sometimes it can burst the container. And as you know that these acid can cause severe burn. That's why we should never add, we should never add water. We should never add water to acid. Instead, we should add, like say, first we should take container, let's take it full of water, and then add acid drop by drop. And that also continuously stirring it so that whatever the internal heat rises, they escape out to the surrounding. So for the dilution of acid, we do not add water to acid. Instead, we add acid to water drop by drop. The last part is this. Ammonia is a base but does not contain hydroxyl ion. So you know that all bases have one thing in common, that they have OH minus ions as common. So whether it's a sodium hydroxide or milk of magnesia is magnesium hydroxide, MgOH, whole twice. Then sodium hydroxide, NaOH. All bases have one thing common, that they have, uh, they have, they releases OH minus ions when they are dissolved in water. Ammonia, if I write the ammonia gas, it is NH3. So you may be saying that, so this does not have any hydroxide or OH minus ions. Then why do we call it as a base? Well, this ammonia gas, which is in fact soluble in water. So when it is dissolved in water, if it is dissolved in water, it is dissolved in water to produce ammonium hydroxide, that is NH3, ammonium hydroxide, NH4OH, NH4OH. And therefore, you can say that it dissociate into NH4, NH4 plus and OH minus ions. That's why we say that it is basic in nature and contain hydroxyl group when dissolved in water. The next question, it says, write the chemical formula of hydrated copper sulfate and anhydrous copper sulfate, giving an activity to illustrate how they are interconvertible. Now, what is hydrated means? Hydrated means, like, as you can see, the copper sulfate crystals I have taken. This is hydrated. Why? Because it has water molecules attached to it, right? It has 5 water molecules attached to it. This is called hydrated copper sulfate, and it is blue in color, as you can see in the picture. But once it is heated, when it is heated, it loses water of crystallization. It will lose the water of crystallization. That means it will turn into CuSO4, and it will, after losing 5 water molecules, it will turn white. So this is anhydrous. This is anhydrous copper sulfate. Now, the question is how they, an activity where they can be interconvertible. That's true. When you heat copper sulfate crystals, right, it loses water of crystallization. But when this anhydrous copper sulfate, when it is exposed to water, right, it absorbs same, that is 5 water molecules and becomes hydrated. Now, we have one more question here in the next part, that is in the second part, they're asking for the chemical formula of plaster of Paris and gypsum. So this is plaster of Paris. The plaster of Paris is CaSO4 dot half H2O. Now you must be knowing the use of plaster of Paris. This is CaSO4 dot half H2O. Chemically, we say calcium sulfate, half for hemihydrate, since half water molecules is attached. Now, next is gypsum. Gypsum is CaSO4 dot 2H2O. That is, we say it calcium sulfate dihydrate. In fact, we get POP from gypsum only when this is heated to 373 Kelvin, that is 100 degrees Celsius. It loses 1.5 water molecules and turns into CaSO4 dot half H2O. And as I said, 1.5 water molecules is removed. And that's how we say it's plaster of Paris. Well, all you have to do is to write its chemical name. This is calcium sulfate. POP is calcium sulfate hemihydrate, right? Hemi stands for and half. And this is calcium sulfate dihydrate.